Hello everyone, thank you very much for watching this communication, and thanks also to the organizer of the International Conference on Teaching, Education and Learning. We are Professor José Manuel Valero and myself presenting Ana Verde, and in this communication we would like to share with you educational robotics applied to early educational stages. So we are going to speak about specifically activities carried out with a robot called Bluebot, as we will see then. So, robots applied to education can offer us many advantages in the training of the student from the early educational stages as well as in the infant stage. So, in addition to offering entertainment, robots are a very powerful tool to motivate students and learn. So this is the content of the communication. In the following communication, we present practical activities using the Bluebot robot. This image is about a Bluebot robot. So activities and resources are presented that allow using this robot in a playful way as a tool for the effective development of the space rationing. So, for this, we will first talk about the importance of the development of spatial conceptions in infant students, and then we are going to speak about this concrete robot. So, it's important to be aware about how educational robotics in early childhood education allows the initiation of the computational thinking and support for the development of the space notions about, for example, directions and left, right, go forward or go backwards. So spatial ability is an important human skill, and we need it for effective learning, for example, for working, for training, and even for playing. So many researchers have pointed that this cognition has a vital skill for developing different knowledge, for example, in mathematics, in drawing, in science, in physical. So spatial reasoning is one of the most functional skills that we have to develop as human beings. And we have a cognitive process by which mental representation of spatial objects, relationships and transformation are constructed and manipulated. And all of that we can improve it with robots. So, if you want to develop the spatial sense in your student, you need experiences for working. For example, with a relationship with, for example, geometrics shapes. So the direction, orientation, and perspective of object in space, you can work with a robot, and also the relative shape and size of figures and objects. So through play, educational robots help children develop these spatial skills from early age. So promote children's geometrical thinking is one of the aspects of spatial cognition, as then you will see in the next examples. The idea for us is create practical and motivating sessions in order to help the students learning with the practice. Today we are going to play with Bluebot. Is this robot? Bluebot is the robot that you can see on the left on the screen. Is this? And on the right we have the Bebot, this type of robot. Both are quite similar. The blue boat, this, allows the children see the mechanisms. And Bluebot, now you can also control it with a tablet or with an iPad, so you have also this functionality for using the robot. In the case of the Bebot, the other robot is not possible to use it. So with this robot, we can programming languages consist only in 5 movement commands. These commands are go forward, go backward, turn left, turn right, and pause. It's exactly 1 second pause. So you can press a sequence of commands which are stored in the sequence memory. So imagine in this case, you can say, okay, so left, left, right, left, left, right, and then when you are finished, you can press go. So if you press go, executes the commands and start the program. If you press the X button, you clear and you erase the memory. It's important to know that you can press a sequence of commands which are stored in the sequence memory. You can store a maximum of 200 commands, and I assure you that that's enough. So when a program has finished, the robot makes a sound and also a light, a flashes. We can use the robot with very different direction from students, for example, for infant students, so with left, right, up and down, and also with older students. Everything will depend on the difficulty of the activity. So next I would like to show you some examples with my colleague. So the activities listed below are suggested in order to progression. There is not any specific amount of time for each one. This varies from the situation to situation. So we will introduce the Bluebot robot and Bluebot app. We will explain that it is a floor robot and it can be controlled from a tablet or a computer. We can explain to our students the instructions, the orders to the robot are sent to the Bluebot via Bluetooth, wireless technology, as you know. So we can talk about robots becoming more and more common in everyday. For example, they are used in factories so to make cars, no? The Bluetooth, or for example, to find helms at vacuum cleaners or other objects. So children can work in pairs or small groups to solve challenges that we give them. For example, an activity we could do this example. Imagine you have a game board like this in your floor. So each group of children has a game board with these images. So, for example, triangle, square, cycle, rectangle of different size and different colors. On the blackboard or in a paper, as you like, you put the different figures, and the student have to program the robot with the directions, the exact direction. Your students have to command the sequence. Other activity, one more idea for finish could be use this Bluebot. We can use a real map to learn geography or a physics map, and with a robot we can do a travel around the world. Children should try to planning a route before pressing go. Imagine I want to go to Tokyo or I want to go to Paris. Other example, imagine your robot wants to work in a hospital and you have to help it. We can go to the waiting room, with the surgery room, etc. So these are different examples that you can use for also work with the abilities from special abilities. So finally, in the conclusions, it's important to know that the programming and robotics tools in early childhood education are not so much for teaching code or creating complex programs and projects. On the contrary, they allow to learn a base of the iterative thought necessary to face a problem. Precisely one of the strengths of teaching programming and robotics in infants is that they are subjects which you can learn much more. So in this case, in the Bluebots, they can be also customized to the teacher taste and include the knowledge that is appropriate. You can decorate also the robot. For example, you can learn different knowledge like parts of the body, letters, words, sounds. This is a lot of possibilities. And finally, also to say that it's very interesting also if you can build a carpet with the different content that you want to learn with your or teach with your students. So it's also like a collaboration with your student. You can decorate the carpet with the figures or with the parts of the body, or depend on the of the content that you want to work. And for us, this is all. We hope you found the presentation interesting. Thank you very much for seeing this presentation, and see you soon. Bye bye. Thank you.